Well, we have already done the connections of slip test, and so this sir I have explained all the connections. So now for this slip test, we need to give supply to the motor. So for that purpose we are using this DC1 supply, 20 volt DC1 supply, and alternator is the field of the alternator we are going to keep open. So that's why there is no need to excite separately this field. So that's why there is no supply is given to this F1 and F2 of the alternator. So only one DC supply is there for the DC motor. DC motor here is acting as a prime mover for the alternator. Then first of all we are going to switch on the DC supply, DC1, and by them, so here we can see the DC1 supply is on. Then by using the 4-point starter we are going to start the DC motor. Now right now we have not switched on the AC supply. You see here the RYB, these 3 wires are connected here to the input terminal of this auto transformer, but still the supply is not given to this RYB. This is off. Once the motor is started, after adjusting the speed to near synchronous speed 1500 RPM, we are going to switch on the AC supply for the transformer. Then we have to create the sleep so that we can take the readings of the direct axis and the quadrature axis. So for that purpose there must be some fluctuation in the voltmeter and the ammeter. So those fluctuations or those oscillations of the pointer of this voltmeter and ammeter we have to bring by varying this field current which is connected in the field of the motor. We can create those oscillations, or the another method is by changing the phase sequence of the transformer. So now right now we don't know whether we will get the oscillations or not. So we are going to start the motor, we will see, and then we will, if we are not able to get the oscillations on this voltmeter and ammeter, then we will change the phase sequence. Otherwise the setup is, we will carry out the same setup. So right now I am starting motor with the 4-point starter. So I am putting this switch on here. So 3-phase AC supply is on, RYB. Right now I have not applied any voltage on the alternator. So we can see here there is a 0 voltage and 0 current is here in the ammeter. Now slowly I am increasing this voltage. Check. So around 10% of the rated voltage I have applied. Now we have seen here there is no oscillations on the voltmeter, or very slow, very little bit of oscillations are there which are very slow. So now I need to increase, I need to create a speed by using this speed rheostat. So I am increasing the speed. Subsynchronous. So it will be subsynchronous speed. Now here you can see there are variations in the ammeter. So again by adjusting the voltage, I will check whether, because we need to take the maximum value of the current and minimum value of the current, as well as maximum value of the voltage and the minimum value of the voltage, so that we can take the reading, we can determine the value of XD and XQ. Rated current of the alternator is 4.3 ampere, so there is no problem in adjusting this current. Now check. we are going to note down the maximum value of the current and minimum value of the current. So the maximum value of the current is around we can see it is around 2.3 ampere or 2.25 ampere we can say. So please write 2.25 ampere maximum current. And look here, for minimum value of the current is 2.15 ampere. 2.15. Now there are very little oscillations we can observe on the voltmeter. So the maximum value of the voltage is 140 volt and the minimum value is 138 volt. So here this completes our first reading. So now we are going to increase the current by adding this autotransformer number. Yes. So again the maximum value of current is 1.95. Check here. It is 1.95 and it is 1.85 we can see. So 1.85 and 1.95 for voltage. Voltage is maximum value of voltage is 118 volt and 117 volt. So again we can try the another reading, last reading. This is the last reading. Also. So this is the third reading. 2.55 or we can take 2.6. And the minimum value of the current is 2.5. And the voltage, it is 170 maximum voltage and minimum voltage is 168. So we have completed the one set of 3 readings. Now I am reducing this voltage transformer and I am again going to switch off the AC supply. So now again I have to switch off the AC voltage so that my motor can start off and starter should return back to its original position. So now we have taken 3 readings here. These are the values. So now here we have to determine the value of XD and XQ. For XD we are going to take, for XD we need to take the maximum value of the voltage and the minimum value of the current. And for quadrature axis reactance XQ we are going to take V mean, minimum value of the voltage and the maximum value of the current. So now as we have taken 3 readings, we will get the 3 values of XD and 3 values of XQ. And average of this value of XD and XQ we are going to consider in the calculation. Thank you.